Welcome to your lesson on assessing intelligence. Well, I'd like to tell you guys this is going to be super interesting. I can't really promise that, so I'm kind of glad that this is going to be an audio PowerPoint. At the end of the 1800s, the French government decided that all children would mandatorily have to go to school, anywhere from 6 to 14, which meant that there were going to be children who had spent time in school because they were wealthy and children who might be 14 years old and had never even touched a book. And to avoid having some kind of bias in all of this, the French government hired Alfred Binet and Theodore Simon. Those are two men that you must know. And they developed an objective test to predict how the children would fare in school. They made an assumption that all children would follow roughly the same developmental course for intellectual ability, and they developed the concept of mental age. Mental age is what you really want to know. So more often attributed to Binet, but it is Simon and Binet that make this, but they come up with this idea of mentally how old are you as opposed to chronologically how many years you have lived, how old are you? So mental age is a measure of intelligence test performance. Notice it's your performance on a test. It is not really truly your intelligence. Now that goes the same for IQ tests, G scores, all of those things. It's how you did on a test. So the chronological age that most typically corresponds to any given level of performance should be the same as your intelligence test if you're average. So an average 9-year-old should have the mental age of 9. To measure mental age, the two theorized that mental aptitude has a general capacity and it shows up in various ways, and they called this aptitude, capacity to learn certain abilities. Binet hoped that the test would be used to improve children's education. He was very fearful that it be used to label them and limit their opportunities, and unfortunately, the latter tends to be more true than the former. Later comes Louis Tremaine, and Louis Tremaine did not work alongside Binet, but he is known for what's called the Stanford Binet Intelligence Scale. Now, it's in its fifth edition, and this was updated by Louis Tremaine, who was a Stanford psychologist, but it was based off of the study and the research developed by Binet, hence the Stanford Binet Intelligence Scale. You need to know this. So it is a slight deviation from Binet's original intelligence test, and it's used for people on the ages or from the ages of 2 to 90. Now, some people will want to give Tremaine credit for the IQ. Technically, the term intelligence quotient and the actual equation for IQ is attributable to William Stern, who was a German psychologist. This you need to know. So please memorize this. Okay, so score of an intelligence quotient, your IQ score, intelligence quotient score, used to be what was your mental age divided by your chronological age times 100. So if I'm 38, that's my chronological age, my mental age was 38, and I timed that by 100, what do you think my score would be? It would be 100. So I would be as average can get. 100 is an average score, which means that if you have a mental age that is younger than the chronological age, the person has an IQ score less than 100. If they have a mental age that is older than the chronological age, then the IQ score is above 100. However, this is what we called a ratio IQ, and we no longer use this. The new approach is what we call a deviation IQ or a normal distribution IQ. As soon as you see the word normal distribution, think bell curve. So now we look at you in comparison to your peers at the time that you took the test, and we slap your scores into a bell curve. Deviation IQ, the one we use now, scores based on a person's relative standing in his or her age group, how far above or below the average person's score. So it's relative to other scores, not just a formula. And one thing we do know is that IQ scores are not very dependable before the age of 6, so you may have a genius 2-year-old that turns out to be an average 12-year-old. Here's your normal distribution curve. I've told you guys before in statistics that you need to know the percentages, but this time you absolutely need to know them because I will be asking questions about them. So what you should know is that standard deviation is 15 points. So when we look at IQ scores, 15 points is your standard deviation. Anywhere from 85 to 115 is within one standard deviation, positive or negative, of the average. So 68% of people have what we would consider average IQs, 85 to 115. The most average being 100, like I told you, that's dead smack in the center. Then roughly about 14% from 115 to 130, we'd call those people highly intelligent. About 2% from 130 to 145, we'd call those people just borderline genius. And 145 on up, those are Mensa candidates. Those are people who are highly, highly, highly intelligent, or we'd call them geniuses. Here's the sustainability or reliability of IQ scores. The reason that there is such a huge increase in the graph from 3 to about 6 is that you're learning to read, you're learning to write, you're learning to tie your shoes, you're learning to make sense of cultural norms, you're learning. Strangely enough, after about high school, so kind of track up where you're about 18, there's not a huge increase, it's a steady increase. That means that you're essentially just adding little bits onto what you already know and you're just improving. You will never have the same growth of knowledge from, I don't know, 15 to 18 that you would from 3 to 6. Other intelligence tests that you need to know. You need to know the Wechsler scales, and there are 3 different types. So this includes a verbal and a performance scale. It can only be administered by a psychologist, usually a school psychologist, not by anybody else. And if you find something on the internet, it's going to be some kind of watered down version of it. There's the WPPSI, which is for preschool and primary age. So just see the PSI as preschool. The WISC, which is going to be school age, so SC, school children, and the WASP, which is adults. I just have the A in there, so adults, 16 on up. And again, here they're going to compare the individual's performance with his or her grade level, and an average score is again 100. So an IQ score, whether you're using a Wechsler scale, whether or not you're using the Stanford-Binet, all of those things, what they give you is a relative measure, you in relation to your peers. The performance part of a Wechsler scale is usually nonverbal, solving problems, completing pictures. We'll look at all of this on the next slide. Verbal intelligence, your language intelligence, your ability to answer questions, including verbally answering arithmetic questions and other language tasks. The aptitude tests are designed to predict your ability to perform a new skill. However, an achievement test, which is what you take in my class, reflects what you have learned. So many IQ tests have aptitude parts. They want to know or predict what you can do. So this is a general kind of mock-up of what you might see on a Wechsler scale. So here's your verbal. There are questions. They would be read to the person. So things like digit span. Listen carefully when I am through, say the numbers right after me. If you notice, they give them 6 numbers. It's 7 plus or minus 2. It's enough for them to manage in their short-term memory. The next set, they have them say it, and then they want them to repeat it backwards. Again, primacy and recency might pop in here, but it's a 5-digit number or 5-digit number. It's at the very bottom of your short-term memory. So other things, comprehension, why do people buy fire insurance? All of these things are going to be verbally responded to. Now on the performance one, what you notice is there's a puzzle, there's a picture arrangement that might be biased if you've never built a snowman or never kind of been in an area with snow, but they would assume that most kids can logically figure that out. Block design, even picture completion, what's missing here on the calendar, well, the month is. So all of that is going to be the performance aspect, something that the person physically does, as opposed to the verbal where they just verbally respond to. Measuring the quality of tests, they have to be standardized, they have to be quantifiable, and the reason we use them is they're economical and they're efficient. They are tools. Tests are assessment. They let us know where you are with your knowledge. So the reason that I let you guys retest in my class is because your first assessment might not be your very best. So you may need to do it again. You may need to show me that you've learned more, which is also why I require you to give me your study guides. It's to prove that you've mastered content. Standardization, reliability, and validity will be the next concepts we talk about. So standardization, if we're going to standardize something, we have to standardize it against a group of people that are going to be our population. So the population that we try to match often is the US Census. So we're going to take a test and we are going to distribute it, and we're going to distribute it to a representative population. They're going to take it. Anything they get absolutely right and anything they get absolutely wrong will probably get tossed out because they won't be within kind of the realm of what people can accomplish, and we'll keep the heart of the test. So each time tests are administered by psychologists, they have to follow a specific protocol, which also is part of standardization. Anytime you take the SOL, you'll notice that teachers have to read the exact same instructions, even if it's the 70th time you've taken one. It keeps it the exact same regardless of what school you're taking it in. Test results from normal distribution or normal curves will happen. So again, the normal curve, the bell-shaped curve, most people will fall within that kind of C range of the 68% or so, but you'll have outliers. And again, as you get further and further out, you should have fewer and fewer outliers. Here you go again. Here's your 68, your 14, and your 2. Please keep that in mind. And again, they're looking at the IQ scores, which has a 15-point deviation from the average. So your average deviation is 15 points. So IQ scores increased over several generations, the idea that people are becoming more intelligent. In your next slide, I'll reference the Flynn effect, but we'll talk about it here. So when we look at this, test measured fluid intelligence, your ability to process quickly, versus crystallized intelligence to require you to learn the solid information that you knew before. Usually larger gains are measured by fluid IQ tests. The reason that we've seen larger gains, better nutrition, levels of education, greater technology, and again, we're a much more complex and multicultural world, so we have access to other people. Are we getting smarter? Our IQ scores have increased since 1910. Yeah, we've gotten smarter. There are other studies out there that will say that maybe we have not, or we're starting to stagnate. So just for right now, go with what's on the next slide, which should be the Flynn effect. The Flynn effect. That's the term for an average person's IQ score 80 years ago is lower than that of the average person today. It either suggests that the test is flawed or that we have gotten smarter. You need to know the Flynn effect. It is the answer to one of the questions on your test. Literally, what is the effect that states that we have gotten smarter? It is the Flynn effect. So while this is not an overwhelming slide, please commit it to memory. Other things that we need to look at is reliability and validity. So I like to remember reliability and validity two ways. One, if I had a reliable car, it will do exactly what I want it to do every single time. And I want to take it to a valid mechanic, someone who is actually certified in doing what I want them to do with my car. So you can do test retest to check to make sure that your test is reliable. Give someone a test, have them take it again. If they come back with relatively the same score, it's probably a reliable test. Alternate form. Give people the same test but in different forms. If they all come back with relatively the same scores, you're probably good. And then split half reliability. I could not use this on my test because I do a review portion and a new portion and they are different. But let's say everything was mixed up. I could take the first 50, compare it to the second 50 and figure out whether or not the test is going to be a reliable test of your knowledge. Validity is going to be a little bit different, and here's where you need to know the difference between content validity and then what we'll call criterion validity. So does it measure what it intends to measure, as opposed to, do you get the same results every time? Same results every time, reliability. Did it measure what it was supposed to measure? That's validity. So content validity, the extent to which a test samples the behavior of interest. So if I give you guys a test, did I cover the content? Well, my test will assess that. If it's a valid test, I covered the content that was meant to be covered. Criterion validity and predictive validity kind of go hand in hand. So the behavior that a test is designed to predict, the measure used in determining whether the test has predictive validity, and here predictive validity kind of comes in as a subcategory. So notice in criterion validity, it basically kind of gives a shout out to predictive validity. So criterion validity. If you do well in the SATs, will you do well in college? Well, it's meant to have high predictive validity. The criterion that they use should have a good predictor. So yeah, if you do score well in an SAT, that's why different colleges require different SAT scores. You should do pretty well. Again, there's going to be other things that you have to keep in mind, like can you study on your own and what was your GPA? So it's not the only thing they look at, but it has pretty decent predictive validity. The test predicts the behavior it's designed to predict. So criterion validity and predictive validity, they're buddies. Content validity, that is the content that you're being tested on, is it valid? Have you been exposed to it? So when we're looking at things like predictive validity, the greater the range, the greater the predictive validity. When you start to narrow a range, chances are you start to minimize how predictive something is. So if I ask you whether or not a football lineman will be successful based off of weight, and I give you 100 to 290 pounds, we'll say, yeah, there's a great correlation. We can see that line going straight up. But let's say we go 250 to 290 with that restricted range, the predictive validity of that test diminishes. In other words, you were to look at the dark pink part, you wouldn't see any real change. It's very minimal. It's going to be pretty much a null correlation. When we look at mental abilities over a lifespan, you need to know the difference between crystallized intelligence and fluid intelligence. The way that I remember these things, crystallized intelligence, crystals are hard and they grow over time. Rivers are fluid and they run fast, but they can dry up. That's just my mental way of doing this one. So changes happen in age-related kind of growth with intelligence. Crystallized intelligence is accumulated knowledge and verbal skills. It increases with age. So as you get older, you get a better vocabulary. You remember more historical facts. You have more experience. You tend to be better. Fluid intelligence. The ability to reason speedily and abstractly. In other words, your ability to get a brand new piece of technology and push all the buttons until something works. is much greater than that of, say, your grandparents. Your parents is going to be greater than your grandparents, and yours is probably better than your parents. It's just how it works. As you get older, your fluid intelligence starts to decrease. It decreases. It doesn't get eliminated, it just decreases. Cross-sectional versus longitudinal research on crystallized versus fluid intelligence is something I'll probably try to cover in class. But again, when we look at this, we're looking at a type of verbal intelligence, inductive reasoning in the cross-sectional method produced declining scores with age. It says that, again, this type of crystallized intelligence decreased. But when we looked at it with a longitudinal research method, we see a slight increase or a rise as people get older. And the question is, why does this happen? We'll look at it on the next slide. So here's what this is talking about. Here's the thing. If we're looking at things like cross-sectional versus longitudinal, longitudinal suggests stability, and that's because it's looking at the same people over time. Cross-sectional, if we have something like the Flynn effect, or if we're looking at fluid intelligence, you're going to see a decline. That as people get older, their ability to reason abstractly or quickly starts to decline. And really, that's not true. You see with the longitudinal that that's a more representative kind of curve. The cross-sectional, you might be comparing a 10-year-old who has had an entire life's worth of technology with a 6-year-old who really hasn't had a lot of access to brand new technology. Comparing the two, the 6-year-old in the cross-sectional study would appear to be stupid. They're not. They have greater technology use than they had when they personally were 5. And that's what you want to look at. So IQ changes over the lifespan. After adjustments for education, verbal intelligence scores hold steady with age. Non-verbal intelligence scores start to decline. So again, we're talking about crystallized tend to hold steady or grow with age, where we're looking at the fluid intelligence, they start to decline. Easiest way to kind of remember one of these things, our great historians always tend to be older. They tell great stories. Literary, they're usually older. It's when you get to the people who are cutting edge in technology or mathematics or physicists, they always tend to be a little bit younger. It's because they rely more on fluid intelligence. Here again, verbal scores versus nonverbal, nonverbal being fluid, verbal being crystallized. Crystallized stays relatively steady. Nonverbal or those kind of fluid intelligence abilities seem to decline. You should have an idea of what the term mental retardation means. And when used in this class, it is not meant to be rude, demeaning. It's meant to be diagnostic. And that is going to be someone who has an IQ score below 70, so 2 standard deviations below, and they have to have difficulty adapting to the demands of everyday life. And it can go anywhere from mild to profound. Reasons or organic causes that can happen to this, you don't need to be that in depth with them, but have a general idea. Physical disorders, birth injuries, damage while they were in utero, whether it was drug use or a disease, metabolic disorders. There's one that has to do with whether or not you metabolize certain sugars. And then you can have a genetic abnormality like an extra gene, which you would see in Down syndrome. Those can all be reasons for diagnostic mental retardation. PKU you need to know. So phenylketonuria. Know this one. I know it sounds like it's not that big of a deal. Know it. PKU is going to be a genetic disease. You have phenylpyruvic acid that accumulates in the body. Children are tested for this regularly, and by age 3, if it goes untested, severe retardation can start to occur. But the great thing is it's a really quick blood test. It's a heel prick when they're first born. They run the screen, and you just adjust the diet so you know that there's no things like aspartame or NutraSweet in their diet. You just have to look for artificial sugars. It's something that can be controlled for, but if you have the genetic disease and you don't know about it, it can become bad. But today, especially here in America, we don't have to worry that much, especially if you go to your doctor and you get your children looked after very well. Microcephaly, hydrocephaly, cretinism, all of these things, general idea, PKU is far more important. Microcephaly, head and brain are abnormally small. The brain is forced to develop in limited space. Hydrocephaly, it's normal, but there's enlarged ventricles, so fluid actually crams into the space and still again stunts the growth of the brain. Cretinism, stunted growth and retardation caused by insufficient supply of thyroid hormone. And again, those you're not going to get tested on as heavily. Make sure you know PKU. Down syndrome is definitely one that you should be able to recognize, and this is something that increases with age, your risk. It is due to an extra chromosome, so trisomy 21. This extra chromosome is going to be the results or will result in this disorder. It doesn't run in family. There's an equal chance throughout the entire population you get it. As you get older, your risk increases, specifically for women, but men can contribute it as they get older about 25% of the time, but we're talking about much, much older fathers. It is detectable before birth, but the ways that we have, the methods that we have right now, the initial test is not that reliable. So you usually have to go for what's called an amniocentesis afterwards to have it verified, and it's a scary time for a woman. If we had time in class, we could talk more about it, but there is no cure. So really what it does is it gives a parent the chance to prepare for a child with special needs. Fragile X syndrome. Not really going to see this one on a test as much. You might, but really Down syndrome, PKU, those are the ones you want to look at. Runs in families. It's sex-linked, mainly affects boys because it's going to deal with an incomplete X chromosome. So men, since they only have one, they don't have a separate X to kind of make up for it. They'll suffer from hyperactivity and attention disorders, and then as they get older, they become more severely retarded. When we look at intelligence, again, here you have the range, and as the IQ score gets lower, notice that the adaptation to the demands of life also become much less. Last slide. Okay, giftedness. When we look at people who are gifted or giftedness, they have high IQ scores, usually 2 standard deviations above the normal, so an IQ of 130 or higher. This was studied by Tremaine. There's some actually really good and interesting research out there that shows that we are now starting to ignore our gifted children and assume that they are independently academically successful and they don't need our help. And the problem is that those children need our help just as much as anyone else. And in fact, they may start to feel left behind, or they may struggle without any guidance. They are not guidance-free learners. They still need guidance. The last one we have is, again, one major learning disability, and I wish we had more time to get into it. And if you guys are interested, by all means, we can spend some time on this later. But people with learning disabilities, often their academic performance doesn't measure their intelligence. Dyslexia would be a common one. And it's not just mixing up words. It literally is their ability to decode language. So when we start looking at something like that, people with learning disabilities, they can be academically successful. In fact, they are equally successful as other people. They just need some modifications once their disability can be identified. So it's like any other disability. Given the right support, they can do exactly what everyone else does. They just have to kind of find a unique and individual way to get about it. So that's everything that you guys need to know for assessing intelligence. We will spend a lot more time on the other two topics, but thank you for understanding about the surgery and being willing to do it this way. I hope you guys have a good Monday. I hope you have a chance to kind of relax in class, and I will see you on Tuesday.